Okay, looking at MRS number 8. Now we're going to go over questions 7 through 10. I will go over number 6 with you together, so I'm not going to cover it on the video. So we'll look at number 7 through 10. Number 7 is, how much money does Malik need to buy 2 rugs and a crystal vase? Again, how much money does Malik need to buy 2 rugs and a crystal vase? Okay, in the chart there, it tells you the crystal vase costs $54. A crystal sculpture costs $932. A chandelier costs $410. And a rug costs $335. So again, in this problem, they only want us to, they're asking us to buy 2 rugs and a crystal vase. So the crystal sculpture and the chandelier, we do not need to know that information. They put that in there just to kind of confuse you. We do not need to know that. So let's look at this. We know that the crystal rugs, or excuse me, the 2 rugs that we need to buy, they cost $335 a piece. That's not for 2, that's just for 1. And then we know that 1 crystal vase costs $54. Okay, so in order to determine how much we're going to need altogether, we're going to have to do some addition. Okay, and I'm not going to do that with you. But just know that the 2 rugs, they're $335 a piece. So this is for 1 rug. Okay, so don't get confused by that. That's for 1 rug. Okay, so you need 2 of those. And then you need to buy a crystal vase, which costs $54. Okay, don't forget to label your answer with have a money sign with your answer when you're finished. Okay, let's look at number 8. Number 8 says, put the following measurements in order from least to greatest. 1 ton, 1,061 pounds, and 24,416 ounces. Okay, so let's look at this problem. Okay, just so you know, 1 ton equals the same thing as 2,000 pounds. Okay, so that's what 1 ton is. They give us the other weight they give us is 1,061 pounds. They give us that. And then the last weight that they give us is 24,416 ounces. Okay, so here's the problem when we're comparing these 3. We have to have the same unit of measurement for each one. Okay, this is in pounds, this one's in pounds, but this one's in ounces. So we have to make this into pounds. Okay, and I know that 16 ounces equals 1 pound. Okay, so 16 ounces equals 1 pound. So what I have to do here is I have to figure out how many 16 ounces can I pull out of 24,416 ounces. Okay, so this is going to be something that we have been working on quite a bit. We're going to have to do a division problem to figure this out. I will get you started with the problem, but then you're going to have to finish it. So I set this up like the partial quotient method that we've been doing in class. So the first thing I ask myself is, can 16 go into 2? I know it cannot. 2 is smaller. So can 16 go into 24? I know that 16 can go into 24. And 16 can go into 24 1 time. So I'm going to say 16 times 1 equals 16. Now, using my powers of 10, I'm going to continue on. So 16 times 10 is 160. So again, I just did 16 times 1, and then I added my 0. So the next would be 16 times 100, and that will be 16 and 2 zeros. Next will be 16 times 1,000. That will be 16, and this time I'm going to add 3 zeros. Okay, I'm going to stop there because if I do it again, I'm going to get a huge number. I'll get 160,000, and that's too high. So I'm going to pull out 1,000 groups of 16. Okay, so 1,000 groups of 16. And I know that gives me 16 times 1,000 is 16,000. So I'm going to put that here. And subtract. Okay, I know 6 minus 0 is 6. 1, 4. I can't subtract 6 from 4. So I'm going to cross that off. I'm going to borrow. That will become a 1. And this will become 14. So 14 minus 6 is 8. Okay, so I got you started with this problem. So now the next step, you're going to continue with it. So again, you'll ask yourself, can 16 go into 8? It cannot. 8 is smaller. Can 16 go into 84? The answer is yes. So you determine how many times 16 can go into 84, and then continue with your multiplication using the powers of 10 and continue on with the problem. Then, once you get this answer, okay, once you get this answer, you need to go back and compare it to these two, the 2,000 pounds and the 1,061 pounds. Okay, then you need to put them in order from least to greatest, from smallest to biggest. Okay? Smallest to biggest. And we already know 2,000, we already know 1,061, and then once you figure out the answer for the ounces, how many pounds that is, you can then complete this problem. And again, you'll just put them in order from smallest to biggest, least to greatest. Okay? Let's look at number 9. It says, which appears to be a pair of perpendicular lines. Perpendicular lines. Okay? So real quick, let's talk about what perpendicular lines, what they are. Okay. Perpendicular lines are lines that meet or intersect at right angles. Okay? So again, this is just a quick example of a right angle. As you can see, it's 90 degrees. It's almost like a perfect L. So perpendicular lines are when the lines meet at 90 degrees. So I drew some examples here for us to look at so we can tell the difference. Okay, so the first one here, see where they intersect? They intersect right here. And that is not a 90-degree angle. This right here is not a right angle. Okay, so that would not be perpendicular. Now this one, you can see we have this line going this way, and we have this line going this way, and they intersect perfectly right here at a 90-degree angle. So this one would be perpendicular. Again, this one, okay, we can see it intersects right here. And we know that if this line continued on this way, these two lines here and here are not right angles. Okay, so this would be a no. If we look at this one, okay, we got this line going this way, this line going this way. They meet right here. And again, this one, they would meet at a right angle. As you can see, it has that perfect kind of L shape here. Okay? So that would be a perpendicular lines. Okay? These two lines would not be, because these two lines never meet each other. They never intersect. Okay? So this line's going this way, and this way, and this line's going the same thing. These two lines are parallel to each other. They're parallel, but they are not perpendicular. They don't even meet. Okay, so this would be a no. Okay, last one we'll look at is sometimes you'll see it like this. Now again, remember, this arrow means that this line goes on, it keeps going. So in reality, this line's going through this one just like that. Okay? And again, this one's continuing on this way. So again, if these lines met right here, they intersected right here, they would not form a right angle with each other. Okay, so that would not be a perpendicular. Those would not be perpendicular lines. Okay, so again, perpendicular lines are lines that meet or intersect at right angles. So when you look back at your examples or your choices, which meet at a right angle? A, B, C, or D? Okay, and the last question, number 10. It says, over a period of 8 years, Josh, the wonder dog, was petted by an average of 59,850 people per year. How many times was the world's most petted dog petted? Okay? So, let's look at this one. So, we know the information that we know, that it was petted 59,850 times a year, and it was petted for 8 years. Okay, so what we need to determine is how many times was the dog petted. Okay, so again, each year, 59,850 times it was petted. That's for 1 year. Okay, so 1 year. They want to know how many times it was petted in 8 years. 8 years. Okay, so this is going to be a multiplication problem. Okay, because we know that the 59,850 is for 1 year, and they did the same thing for 8 years total. So we would have to find out, each year would be 59,850. So it is a multiplication problem. So now you can do it several ways. You can do it the standard algorithm way, the way you kind of knew coming into this year, or you can do it using the area model. Okay? And if we set it up using the area model, I'm just going to put the number here so we can see it. So it's 59,850. So I know this number here represents 50,000. This number here represents 9,000. This number here represents 800. This number here represents 50. And there are no ones. Okay? And then I know this number would be 8. Okay, so you could do it using the area model as well. Okay, and then once you get that answer, just make sure you label it. All right, so again, don't forget to show your work and make sure you label the word problem.